Hey, I'm Mitchell. Welcome to another video in the RSP Education series. Imagine a robotic arm on an assembly line. Now imagine it misplaces a part by even just 1/10 of a second. Or worse, an emergency stop signal that takes too long to trigger. In industrial automation, a delay of even milliseconds can mean broken machinery, defective products, or unsafe conditions. In this video, we're going to dive into one of the most critical but often misunderstood aspects of automation, which is how communication protocols affect timing, precision, and reliability. Welcome to video 6 of our series on industrial automation communication protocols. Today, we're going to break down the difference between deterministic and non-deterministic communication and why choosing the right one could be the key to keeping your entire operation running smoothly. If you like this kind of content and want more education videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So, deterministic versus non-deterministic communication. In industrial automation, machines, sensors, and controllers, they need to communicate quickly and reliably to keep operations running smoothly. So, how fast and predictable data is transmitted can mean the difference between an efficient system and costly downtime. For example, what if a robot arm misplaces a part, like we said, just 1/10 of a second? Or an emergency stop signal takes a second too long to trigger. In industrial automation, timing isn't just important, it's everything. So, deterministic communication, it's predictable, it's timed. What does it mean? Data is delivered at exactly the right time, every time with minimal delay. In industrial automation, it's used for real-time control in robotics, conveyors, motion control, and manufacturing lines. It makes sure that commands reach devices on time to prevent breakdowns or misalignment. A good metaphor for deterministic communication would be a train schedule. It leaves and arrives at fixed times, whereas non-deterministic communication is more like highway traffic. You might get there quickly or you might get stuck. Deterministic protocols often require specialized hardware, though, and precise configurations can increase the system cost and complexity. Non-deterministic options offer more flexibility and are easier to scale or integrate with cloud systems. A real-world example would be an automotive assembly line that's using EtherCAT to control robotic arms with split-second precision, while its quality control cameras log images to a cloud database using OPC UA protocol. You want to use deterministic communication for motion, timing, and safety-critical tasks. So some examples of deterministic protocols, starting with Profinet IRT, which stands for isochronous real-time. It makes sure that there's precise timing for motion control. EtherCAT, that's another one, delivers data in a fixed time window for high-speed machine automation. Then you have something called SERCOS, S-E-R-C-O-S, used for real-time CNC and robotics control. So why is deterministic communication important? Like we've said, if a robot arm doesn't receive its movement commands on time, it could crash or misplace a product. In a conveyor system, delayed data could cause bottlenecks and production errors. So why real-time performance matters in automation? It ensures machines operate in sync, right? Motors, actuators, sensors, they all need to react instantly. It prevents downtime and failures. A late response can jam a production line or damage equipment. Increases safety. Real-time data is critical for emergency stops and system protections. Deterministic communication in real time also improves precision. High-speed automation is going to require exact timing to avoid defects. So let's recap. In industrial automation, timing is everything, and that's where the difference between deterministic and non-deterministic communication becomes critical. Deterministic protocols like EtherCAT, Profinet IRT, and SERCOS deliver data at precise, predictable intervals. It makes them ideal for real-time control within motion systems and safety-critical operations. Non-deterministic protocols, on the other hand, they offer a lot more flexibility and scalability, which makes them great for tasks like cloud logging, monitoring, and non-time-sensitive data exchange. Think of it this way. Use deterministic protocols when timing and precision are non-negotiable. And then you're going to use non-deterministic protocols when adaptability and integration are more important than split-second performance. For hundreds of thousands of industrial automation products, go to our website. That's rspsupply.com, the internet's top source for industrial hardware.